Hello everyone, this is Nagesha Rao, Assistant Professor, Department of Civil Engineering from NNRG. As today we will discuss one topic from Transportation Engineering of second unit, that is Highway Geometric Design. So there is a topic is design of super elevation and extra widening. So what is a super elevation? In order to contract the effect of centrifugal force and to reduce the tendency of vehicle to overturn, the outer edge of the pavement is raised with respect to the inner edge, thus providing a transverse slope throughout the transverse length of the horizontal curve. This transverse inclinations to the pavement is known as super elevation or contract super elevation. E is expressed. So here E is equals to NL upon ML is equals to tan theta. So this is from triangular section. E is equals to super elevation. E is equals to tan theta. We can say from here. So this adjacent by hypotenuse we can take here. So then E is equals to tan theta we can say here. So some of the analysis of super elevation. So the force acting on the vehicle while moving on a circular curve of radius r meters at a speed of v meter per second. Number one is the centrifugal force. P is equals to Wv square by gr acting horizontally outwards through the center of gravity Cg. Another point, the weight W of the vehicle acting vertically downwards through the Cg. Another point is the frictional force developed between the wheels and the pavement contractions transversely along the pavement surface towards the center of the curve. So here the formula is E plus F is equals to V square by 127 R. So here V is equals to V square by 127 R we can say. So E is equals to V square by GR and F is equals to also V square by GR. We can say here V square by 127 R. So we can say another formula is equals to E plus F is equals to V square by 127 R. Here the V is equals to under root of 127 R into E plus F also we can write here. So here E is equals to ratio of super elevation and F is equals to coefficient of fraction between tiles and pavement, that is the 0.15 value. V is design speed kmph, R is equals to mean radius. So here some value is given IRC. Super elevation should be limited to the following values. The plain and rolling terrain, it is the 7%. Already we are discussed in second unit of first topic, and 1 in 15. In hilly terrain it is a 10%, in 1 in 10. On urban roads is 4%, in 1 in 25. So guys, this is the super elevation. So inner side is value is less and outer side is transferring the length. So that's why compared to the width will be maximum from inner side to the outer side. So we can say like this. So weight of the vehicle is downwards. We know centrifugal force is P and frictional force also is there here, F1, F2. So some of the objects of the providing super elevation. It counteracts the effect of the centrifugal force acting on the moving vehicle to negotiate a curved path without overturning and skidding, to ensure smooth and safe movements of passengers and goods on the road, to prevent damaging effect on the road surface due to improper distribution of load, and the maintenance cost of road on curve is reduced. So some of the super elevation depends on following factors: the coefficient of friction between tires and pavement, speed or design in kmph, and radius of horizontal curves in meters, and topographical conditions. So that is the super elevation, guys. Another point is there here, extra widening. So extra widening is there. On horizontal curves, especially when they are not of very large radius, it is common to widen the pavement slightly more than the normal width. At the curve section only, we can do this kind of the work only. The object of providing extra widening of pavements on horizontal curves are due to the following reasons. So, some of the reasons is there. So, number one is an automobile has a rigid wheel base and only the front wheel can be turned when this vehicle taken as turn to negotiate a horizontal curve. The rear wheels do not follow the same path as that of the front wheel. Absolutely all vehicle is like that only. So that's why backside vehicles is not wheels not following the front side of the wheel. So that's why some extra widening is required at the radius point. And this phenomenon is called off tracking. Normally, these rear wheels follow the inner path on the curves as compared with those of the corresponding front wheel. So front wheels is passing from outer path and in rear wheels are following the inner path. So that's why at the inner path place is need more. And the speed higher than the design speed when the super elevation and lateral friction developed are not fully able to counteract the upwards thrust due to the centrifugal force. Some transverse skidding may occur at that particular point. And in order to take curved path with a large radius and to have greater visibility at the curves, and the driver's tendency not to follow the central path of the lane but to use the outer side at the beginning of the curve. And here two type of vehicle cross sections is there we have. So one is the mechanical widening and another one is the psychological widening. So this is the image, widening of the pavement on the horizontal curve. We need to require outer zone. So here the mechanical widening, the widening required to account for the off tracking due to the rigidity of wheel base is called the mechanical widening. So here the value is Wm. So mechanical widening is equals to NL square by 2R actually here. NL square by 2R, that is a mechanical widening. And here the psychological widening, extra width of pavement is also provided for the psychological reason, such as to provide the greater maneuverability of strings at a higher speed and to allow for the extra space requirement for the overhangs of the vehicles and to provide greater clearance for crossing and overtaking vehicles on the curves. So here psychological widening is V upon 9.5 under root of R. So your total widening is equals to mechanical widening plus psychological widening. So this is the total widening NL square by 2R plus V by 9.5 under root of R. So N is equals number of traffic lanes here, L is called length of wheelbase on longest wheel. The value of 1 may normally be taken as 6.1 meter or 6 meter for the commercial vehicle. V is the design speed and R is the radius of the horizontal curves. Thank you.